Okay, let's try a few problems from the past year test 2. Okay, please refer to your notes on page 26. So for the first one, find the inverse to the Fs given in that form. So finding the inverse to the Fs, okay, meaning that we want to find the inverse to the exponent negative s over s square minus 3. Okay, you can separate into two inverse. This is by the linearity property. Okay, separate into two inverse. So let's assume this one as part A and this one is B. Okay, so we'll solve it individually. So for part A, okay, the inverse to the exponent negative s over s square minus 3. Okay, so we need to refer to the table and try to map. Okay, try to map to the right hand side of the table. Okay, so you have exponent negative s over something. All right, so if we refer to this table, okay, you have exponent multiply, okay, or divide by something, or can be seen as exponent times something. All right, so on the right hand side here, okay, so from the top here, you don't have the exponent multiplied by something until here. Okay, so starting from here, you have the exponent. Exponent negative as over s, exponent negative as times fs, the exponent negative as alone, and then exponent negative as times fa. Okay, so you have these four. Okay, so map to the most similar. Okay, the most similar form. So just now we have exponent negative s over s square minus 3. Okay, so even though you don't see the division, okay, somewhere here, but the expression that we have is actually can be seen as exponent negative s times 1 over s square minus 3. Okay, so the most similar term is this one. Okay, exponent negative as fs. So the answer that we are supposed to get, okay, at the end should be in this form. So ht minus a, so this part is not, okay, a problem. You just substitute your a, but this part. So you need to get what is the expression for the ft minus a. So this is actually your task. Okay, so we go back to the problem. So this one, okay, just now we map to the inverse to the exponent negative as fs, where the answer is supposed to be ft minus a ht minus a. Okay, so let's put as asterisk here because we are going to refer to that later. All right, so now by mapping to those two, okay, then we know that our a is then, okay, so we map exponent negative s to the exponent negative as. So we know that our a is 1. Okay, and then the fs would be 1 over s square minus 3. Okay, so the question is this one. How do you get the ft minus a? Okay, so the idea is if we know our ft, then we can get for whatever t minus, okay, any value. Okay, so what we need to get is actually ft first. So ft is the inverse to the fs. So ft is the inverse to the 1 over s square minus 3. So now look back at your table, okay, find which one is the most similar expression at the right hand side of your table. All right, so this one, okay, if you refer to the table, this one is mapped to, okay, a over s square minus a square, which is shine at. Okay, so now, okay, we need to do a bit of manipulation because what we have, okay, what we have here is 1. Okay, in the table it is a. Okay, so a little bit of manipulation needed here. So this is inverse, Okay, so take care of the denominator first. So s squared minus, okay, so in the table, it should be a square. So since we have 3, in terms of square, it should be square root of 3 square. Okay, and you see at the top, it should be a. So a is square root of 3, but we already changed the expression. Originally, it is 1. Okay, so in order to get back the 1, we need to multiply this one with a 1 over square root of 3. Then we have the equivalent form. Okay, so what we have here is actually equivalent to this. All right. So now by the linearity property, we know that 1 over sec3 can be put aside. So what's left in the inverse is square root of 3 over s square minus square root of 3 square, which is sine a. So a in this case is square root of 3t. So that is our ft. Okay, so now from the star here, so what we want to solve is the inverse to the exponent negative s square minus 3. So it should be ft minus a. Okay, so since our ft is 1 over sec3 sine sec3, so at the t here, we put t minus a. So our a is this. Okay, so t minus 1. And then follows with h t minus a. So h t minus 1. That's it. Okay, but this is only for the first part. We still need to get the second part, which is b. So b is the inverse to the, okay, 6 over s cubed. Okay, so in part B here, so we have this. We need to get this one. So the inverse to the 6 over s cubed, now refer to the table. So the most similar expression is the one that involved with the t power of n. So we have here n factorial over sn plus 1. Okay, so now try to manipulate the expression so that we have in the form of n factorial over sn plus 1. Okay, so this one is equal to the s cubed comes from s square plus 1. So at the top, it should be n factorial, which is 2 factorial. Okay, but we are not complete yet. So this one, okay, originally it is 6. So we need to multiply with 3. So that 3 times 2 factorial is 6. Okay, so by the linearity property, this is then 3 inverse of 2 factorial over s2 plus 1 is given by t power of n, which is t power of 2. So this is part B. All right. So now our answer, okay, if we go back to the original expression, the final answer should be a plus b. So we put together, therefore the inverse to the fs is equals to the solution in A plus solution in B, which is, okay, what we have earlier, 1 over square of 3 sine square of 3 t minus 1 h t minus 1 plus 3 t square. Okay, so this is actually the angle for the sine. Okay, so that's the first solution. Okay, so we will look at the another example. For problem 2, we have gs equals 8 plus the fraction over there. So find the inverse Laplace transform, okay, given the function gs. Okay, so now the inverse to the gs, okay, can be separated into 2. The inverse to the 8 plus the inverse to the exponent negative 2s over s squared plus 4. Okay, so the second term is actually almost similar to what we have previously. All right, so let's put this one as A and this one as B. Okay, look at the first one, A. Find the inverse to the 8. Okay, refer to the table. If we refer to the table, okay, we don't have the constant at the right hand side here. Okay, none. Okay, none of the expression on the right hand side here involve the constant only. Okay, so if we go back to this one. So based on my past experience with the previous students, the very popular common mistake is this one. Students tend to write the answer to be 8 over s. Okay, this is not true. Okay, because this is the inverse function, not the Laplace transform. Okay, so actually the student get confused with this one. So before this, in the first part, you were given ft equals 8 and you were asked to get the Laplace to the 8. Then yes, this is 8 over s. But now the other way around, you need to get the inverse to the 8. Okay, so if we're talking about the inverse, meaning that the answer, after we take the inverse Laplace transform, the answer should be in the form of t. So it is obvious here, if your answer is in the form of s, this is not valid because the answer is supposed to be in the form of t. All right, but it is not 8 over t anyway. All right, so this one, okay, if we take the linearity property, okay, try to take out 8, okay, because normally if we have 8 times exponent something, then we take out the 8. Okay, so we do the same thing here. So this one actually can be seen as 8 times the inverse of, so what's inside now is 1, not 0. Huh? So this is 1. Okay, now refer back to the table. Okay, so if we refer to the table here from the top here. So think of, okay, what is the expression that can get you 1? Okay, so for example, this one. Okay, you never get the 1 because it's always over s. Okay, similarly for this one. So actually from the top up to here, you cannot get the 1 until, okay, I would like to draw your attention to this part here. Okay, so from this expression, exponent negative as. Okay, so when do you get 1? If you refer to this, how is it possible to get 1 from this? Okay, so if you think of exponent of 0, that is 1, then you know that your a is 0. So this is actually 1 when a is 0. So when a is 0, look at the left-hand side. Okay, when a is 0, what happened to the expression here? This is dt minus 0, which is dt. Okay, so the mapping that we should do is actually here. Right? So if you go back to this one, so this one is actually can be mapped to the inverse to the exponent negative as. Okay, since, okay, exponent negative 0s is actually 1. Okay, so this one now is equal to 8 inverse of exponent 0s. In fact, negative 0s. All right. So by the table, okay, if you refer to the left-hand side, the answer should be in the form of del t minus a, where our a is 0. So this is actually 8 delta t. So that's it. Okay, so it simply means whenever you have the inverse to the constant, the inverse to the 1, then it is del t, which is actually del t minus 0. So if you have the inverse to the 8, so it is simply 8 del t. Similarly, if you have the inverse to the 1 over 2, then it is 1 over 2 delta t. So whenever you have constant alone in the inverse, then it should be, the answer should be in the form of direct delta function. Okay, so I hope you can remember that one, because this is quite famous term, okay, to be asked in the exam. Okay, all right, so we've done with the part A. Now part B. Part B is the inverse to the exponent negative 2s over s squared plus 4. It actually can be seen as multiplication of exponent negative 2s with a 1 over s squared plus 4. So similar to the problem in 1 previously. So this one is actually mapped to the inverse to the exponent negative as fs, which is ft minus a ht minus a. Okay, so by mapping what we have, okay, to the table, okay, what we have and map to the table, then we know that in this case our a is 2. Okay, so be careful. Sometimes the mistake comes from this part as well. A equals 2 versus a equals negative 2. Okay, so you are mapping exponent negative 2s with the exponent negative as. Okay, so a is supposed to be positive 2, not negative 2. So a equals 2, then the function after that is our fs. So fs is 1 over s squared plus 4. So find the inverse to the fs so that we get the ft. So ft is the inverse to the fs, which is 1 over s squared plus 4. Again, look at the table. So this one is mapped to the inverse to the constant a over s squared plus a squared, which is sine at. So by mapping 1 over s squared plus 4 to the a over s squared plus a squared, then we know that our a here is 2. Okay, so a little bit of manipulation here. Do the denominator first. So we have s squared plus 4 in terms of a squared is 2 squared. So at the top it should be a. Okay, should be a here, tally with the a at the denominator. So at the top we should have 2. But the original term is 1 over s squared plus 4, not 2 over s squared plus 4. So in order to get back the 1, we should multiply with a 1 over 2. Then they are equivalent now. Okay, so 1 over 2 can be put aside. So what we have is the inverse to the 2 over s squared plus 2 squared, which is directly now sine 2t. So the answer to part B alone, so therefore the inverse to the exponent negative 2s over s squared plus 4, now you go back to this one. Okay, so it is ft minus a. So since we have the ft here, so if we want to get the ft minus a, so we just simply substitute t with a t minus a. So in this case, again, our a is 2. So we have 1 over 2 sine 2. So t here now becomes t minus 2. h t minus 2. So this is part B. Okay, so the final answer should be A plus B here. Okay, so put together. Okay, so therefore the inverse to the GS is 8 part A plus B, which is 8 del T plus 1 over 2 sine 2t minus 2 h t minus 2. Okay, so those are few examples, okay, illustrating how do we apply, how we do a bit of manipulation, how we map to the table, okay, to solve the inverse problem. Okay, so in the next part, we'll go to another expression that involve the fraction which are related to the quadratic function. Okay, so take some time to revise back. Okay, so hopefully you can understand. Okay, if you have anything, any questions, so please do not hesitate to contact me personally. All right.